recording. So today we're going to look at the online Moodle review for the final exam. If you go to the class and scroll all the way to the bottom, you'll see the review for the final exam. If you're Jared or Warren, you'll see two of them. This one is specifically for your 170 class. We're going to be looking at this one today for the 231. Oh, hey, somebody else is joining. Welcome, Claudia. So here's what the exam will look like. This is exactly what it's going to look like with different numbers and tails and all that good stuff, as always. So again, you should know exactly what you're doing before you get in there. It does have a formula sheet at the top, but again, you're welcome to use yours. You will need your tables, so make sure you have that handy. The first one, let's see if I can do something with this. Yeah, put it over here. The first one is just like the first one on the paper-based exam. It's identifying population, sample, statistic, and parameter. And it's just got a little drop-down menu, basically. So same concept, different format. Let's read it. In a study of job satisfaction, local college administrators were given a survey to measure satisfaction with their work. To determine the level of job satisfaction is different from an average of 48. 32 administrators were randomly selected and resulted in a mean of 43.5.
Oh, sorry.
Okay, so all of them, that's the population. That's all the administrators of the population. That's what we're looking at. That's what we're examining. Now, those 32 particular peoples, that's our sample. Now, if we look, the sample, 32 administrators were selected and resulted in a mean of 43.5. That's the sample mean. That's the statistic. 48 is the population mean. That's the parameter. Sample, statistic, they both start with S. Parameter, population, they both start with P. All right, a nice small simile plot to make. So this is how you're going to do it. You're going to fill in your stems and your leaves over here. I guess we'll just separate the numbers by spaces over here. It doesn't say anything in particular. So I see a 5, a 2, a 10, a 0. Okay, so I need a 0, a 1. I guess I can't go down. So you have to click every time. 2, 3, 4, and 5. So zeros, I have, let's see, 8, 7, 4, 9, and 9. So 4 is the smallest. Then I have a 7. Then I have an 8, a 9, and a 9. Maybe commas would be better. I don't know. Doesn't specify. Probably commas would be ideal. So 1, 2, 3, 4, 5 single digits. 1, 2, 3, 4, 5. Okay. Now I'm going to look for the 10 digits. I've got a 10 and an 11. 10 and an 11. I think that's all of those. Now let me look for the 2s. Let's see, the 21, 22, 27, 29. 21, 22, 27, 29. Got no 30, so it says type 3 dashes. Got no 40s, 58. So let's count, make sure we have the right number of numbers, make sure we didn't skip anything. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So most likely I didn't screw up. All right. So referring to the data values here, who cares what it is? It asks for the mean, variance, and standard deviation. So you could use this information, plug them in the formulas, but hey, look, they give us the data set. So I think it would be easier just to type that in the calculator and get it from there. I'll do it on both. So I'm going to do this on both calculators, starting with a Casio. Go to mode, stat, one variable. and type
I
these
can't
in.
see the calculator, Mr. Fuller.
You can't see the calculator.
Oh wait, never mind. I'm sorry. I had my thing zoomed in.
Ah,
That's on
yeah,
me,
that
Coach.
could do it. So 58, 22, 27, 29, 21, 10, 8, 7, 11, 9, 4, 9. So there's 12 of them. There should be. So I'm going to quit out of here, AC. And I'm in stat mode, notice. So I'm going to do shift 1. I want some variables. Number 4. I want the mean, the standard deviation. So first, let's get the mean. 17.91, blah, blah, blah. And here, if you didn't notice, highlighted in bold letters is round your answer nearest 10. 17.9 it is. To get the variance, remember, variance is the square of your standard deviation. So I'm going to take my standard deviation, S, not sigma, that's estimating the population standard deviation, which we do not want to do ever. We want our S. 15.1 would be my standard deviation. So let me go ahead and write that down. And I'm going to square that and get 229.0 for my variance. I said 2, okay, yeah, it's in there. The box is a little small, but there it is. So if you recall, unusual values are 2 standard deviations away from your mean. So I'm going to take my mean and subtract 2 standard deviations here and add 2 standard deviations. So let's see, 17.9, I don't know if this will actually calculate in stat mode, I think it will. Minus 2 standard deviations, 15.1 times 2, negative 12.3. And I'm gonna go back with my left arrow key and change that minus to a plus, 48.1. Are any of the values considered unusual? Well, let's look. Are there any values that are negative? Nah. Are there any values bigger than 48? Yep. The unusual values would be, and there is one, so 58. If there weren't any, which there's possible that you might not have any, you just put 3 dashes. Any questions so far? Okay. Same thing with the TI, real quick. Won't take too long. So here you're going to edit your list. Go to the top, clear, enter, type in your data. Uh, 9, 4, 9. And I got 12 data values, so I'm good. Second mode to get out of there. And then I'm just going to run a 1 variable statistics. Stat, stat, go to the right to calc, 1 variable statistics. And just hit enter a few times. 17.9 for my mean. Standard deviation is 15.1. And it gives you your 5-number summary down there as well. So I'm going to take this 15.1324, 15.132. It was actually 5, it would round to, and I'm going to square that. And I get 228.99, which would round to 229.0, just like we have right here. I'm going to go 4 decimal places because I just want to make sure I don't have a rounding error there. And if you were to do this by hand, you use these formulas up here. The mean, sum of x over n. They give you the sum of x right here. So you just divide 215, go to mode 1, 215 divided by, there were 12 numbers, and you get 17.9. then I'm not actually going to type out the formula because it's slightly lengthy, but you'd use this one, the standard deviation shortcut. It looks a little longer than standard deviation, but it's actually a lot easier because we have this data value here and, well, this statistic here and this statistic here, these numbers. So just plug them in the calculator and you'll get your standard deviation out of there. Take your answer and square it, match your variance. The distribution of overall general satisfaction of life with respect to region for Americans 18 years and older is shown in the table below. All right, so right here, I'm going to read round 3 decimal places. Make sure you don't put fractions. And I'm actually going to write this on my paper because the first thing I'm going to do every single time with these kind of problems is get my totals. And since I can't write on the Moodle test, I'm going to write it on my paper. Well, I'm going to take a screenshot and put it over here, but you're going to write it on your paper. So just get your totals. 20, 14, 30, 44, 5, 7, 13, 27. And if I do this, that's 50, 64, 108. So that's 81. And, you know, use your calculator so you don't make simple arithmetic errors, which I may have done. So to check, I'm going to add these up and make sure I get 81. If I did, I should be all good. 15 plus 12 plus 24 plus 30 is 81. Okay, these should all be good then. That's the first thing you want to do, get your totals. And we also need to read what it says. It has words here, but hey, it says probability dissatisfied or west. So if you remember probability, oh, hey, I think they have that at the top of the formula sheet. Yeah, right here. So probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. So that's exactly what we're going to do. Probability of dissatisfied or west. Dissatisfied, that was 27 people were dissatisfied out of the whole 108 people. Plus west, that was 44 out of the 108 people. Minus dissatisfied people from the west, there were 14 of those out of the 108 peoples. And if you do that, you get, well, it said to use a decimal, but you'd get 57 out of 108. Round it to 3 decimal places, it says, so 57 out of 108 gives me 0.527 repeating. I'm going to round that to 0.528. All right. Okay, now this one, it says 2 Americans are selected without replacement. So we had to read that, make sure you see if it's with or without replacement. If it's without replacement, pretend you're killing the first person and then, you know, they don't exist anymore. If with replacement, well, it's the same probability times itself. So probably that both are from the east. So let me clear this out. No, I almost made a mistake there. Let me just erase this. Okay, probably that both are from the east. So the probability of the first person from the east is 20 out of 108. And you took that person and put them in your secret little dungeon. So now there's only 19 people from the east and 107 people total. Do that and you're done. And we want a decimal 3 decimal places, so 0.033. Try not to suck at rounding. A lot of times you do. All right, next says probability of east. And remember, this bar is read as given that they're satisfied. So we're not looking at everybody. We're not looking at the 108 people. We're looking at the satisfied people. We're looking here in this row. So my total, get rid of this from previous problem. My total is not going to be 108, but it's going to be that 81 because that's how many people were satisfied. We know they're satisfied. 81. Now, how many people were from the east? 15. Boom, that's it. 15 out of 81. 0.185 repeating. So it's just 0.185. And that's how you do that problem. All right. So it says calculate the p-value for the following hypothesis test for sample size of 100, resulting in a test statistic of this. Okay. Notice it has the z here, so we're good to go. On the paper-based test, it didn't say if it was a z or a t, so that was a little confusing. This one is definitely a z, so we're going to look in our z distribution. It's a two-tailed test, and it's a negative z, so that means it's to the left of our mean. So if we look, oh, what's this say? Two-tail. So let's go look at our formula sheet. How do we find the p-value? Well, if you don't remember, you have a flow chart here. It's a two-tailed test. The z-score is negative, which means it's to the left of the mean because the, well, to the left of the center, because the center is 0. So we have to the left. So we're in this little box right here. This is what we need to do. Find twice the area to the left of the test statistic. So I'm going to look up negative 1.56 on the chart, the z chart, right here. Negative 1.5, and then 6 is this column here. Remember, the chart always gives you the area to the left. Well, in this particular case, we wanted the area to the left, so we're going to use this 0.0594. 0.0594. However, if we go back and read, we have to do twice the area to the left. So we're going to do this times 2. It's going to be 0.1188, I think. Yeah, 0.1188. So that would be our p-value. It doesn't tell you to round, so don't. Just use all 4 decimal places. TI users, you don't have all the data, so you can't just type this in a z-test or anything, so you got to do it by hand. You could use the normal CDF function on either calculator instead of using the chart to get that first p-value. I'll do it on the TI. So if you go to second var, that's where your distributions are. It's a normal distribution. Lower bound negative infinity, upper bound negative 1.56. Don't touch those other guys. And it'll give us that first value we found. If we double it, it's going to round to 0.1188. Casio users, we're going to go mode down to get to our distributions. Number 2 for our normal CDF here, lower bound negative infinity. Negative 1 times 10 to the 99. That's a negative 1 followed by 99 zeros. So that's as close to infinity as this calculator will get us. Negative 1.56 for our upper. Leave those alone. And we get this value. We need to double it, so we have to go back to mode 1. Answers times 2, and we get 0.1188. So if you don't like using the chart, both calculators can do it for you. Okay, it says find the Z for the standard normal distribution sketch below. The area to the right is 0.9564. We're using the chart. What does the chart give us? Too much stuff. Chart always gives us the area to the left. So I need to know what the area to the left of this thing is. So I'm going to take 1 and subtract 0.9564. Remember, the area under the curve is 1. That's the whole possible probability. So I'm going to look up 0.0436 in the chart. So it's going to be somewhere in here, 0.0436. These are your areas in here. These are your probabilities. 0.04, oh, hey, there it is. Negative 1.71. So that's my Z-score, negative 1.71. And you could use an inverse norm on either calculator. Same location, number 3. Instead of, well, let's see what happens if we put in the 0.9564. See those in, and you'll actually get the positive 1.71. But you know it's to the left of the center, so you'd actually need to just use the negative value. You could also just do, I'll do this one on the TI. Same thing on either one. 1 minus 0.9564. Leave those alone. And you get the actual negative 1.71. So it's up to you how you do these. If you want to use a chart, go for it. If you don't want to use a chart and you'd like to use your calculator, do that too. All right. Suppose you're conducting the lower tail hypothesis for a sample of 15. The graph is, well, it's a lower tail. That tells us right there it's a left tail. For a sample size of 15, what is the significance of the test if the critical value is this? Okay. Can everybody count? Hope so. How many decimal places does this have? 1, 2, 3. Our Z critical values have 2 decimal places. Our key critical values, 3. So we're going to look on the T distribution for this one. Let's cut square. Now, N was 15, so that means we have 14 degrees of freedom. Oh, hey, look, there's the number exactly right there, 2.977. It's a one tail because it's a lower tail. So I'm going to scroll up here. Area one tail, 0.005. Notice I completely ignored the negative. Yeah, you completely ignore the negative. If it's a left tail, it's negative. It's a right tail, positive. Chart's only got the positives. So you have to correct the sign on it based on if it's a left tail or a right tail. All right, let's see. The weight of male babies less than 2 months old in the United States is normally distributed with a mean of 11.5 pounds and a standard deviation of 2.7 pounds. Part A. If a male baby is randomly selected, calculate the probability that his weight is more than 10.5. Okay. So for this one, it's a normal distribution. It tells you right there, it's normal distributed. So I'm going to use a normal CDF. So I'm going to do these on the calculator. My lower bound is 10.5. It's more than 10.5. So actually, let me write out all this pertinent information. So my lower bound, 10.5. my upper bound, infinity. My mean is 11.5. My population standard deviation is 2.7. So this is for part A. And I guess I can put N as 1. It's a male baby. That's one baby, so it doesn't even matter. If we have more than one, we use the central limit theorem, which we'll do on the next part. So I'll start on the Casio. Normal CDF. Lower bound is 10.5. Upper bound is infinity. This time the standard deviation is 2.7. Do change it. And the mean is 11.5. And we get this probability of 0.64, yada, yada, yada. Okay. Typically around probability set 3 decimal places. Running will apply, I guess 3 decimal places work. I'll check the answer key and see what they have in a minute. Now this is for part A. For part B, what changes? Well, 2 things change. First, it's lower than 11 pounds. So my lower bound is negative infinity. My upper bound is 11 pounds. This guy right here, the mean is not going to change. The standard deviation itself doesn't change. But since we have a sample size more than 1, we have to take our standard deviation divided by the square root of that sample size. So this is what we're going to use. I'll do this one on the TI. Normal CDF. And let me just put something random here. It's going to look like this for you with this being blank. So negative infinity, comma, 11, comma, 11.5, comma, 2.7 divided by square root of 64. Yes, I know that's 8. Who cares? And we get 0.06, yada, yada, yada. So let's go ahead and fill in these blanks. I'll put 3 decimal places for now. I'll see what they say in a minute. Third time's charm. So probability that it's more than 10.5 is 0.644. Question? No, guess not. Probability that's less than 11 is 0.069. Now, are these unusual? No, they're not. We consider 5%. That's our usual. That's our unusual. Our usual unusual value. There you go. 5% is what you're looking for. If it's less than 5%, we call it unusual. This is 6.9%. That's 64.4%. That ain't unusual. Okay. So I guess let's see. I have to turn editing on. Maybe I can do it right here. Where we at? So let's see. Move my face out the way. Okay, so it looks like they have 2 decimal places. Oh no, 4 decimal places. Oh, okay. Well, I guess it doesn't matter. Okay, so here's how it goes. 100% for 2 decimal places. 100% for 2 decimal places. So I guess we can go 2 decimal places. I guess they consider this one to go 1 decimal place further than the. Oh, I lost everything. Oh well. So let's look at this one. A sample of 26 hip surgeries of a certain type. The average surgery time was 136.9 minutes, with a standard deviation of 22.6 minutes. To estimate the mean surgery time of all hip replacements with 90% confidence. All right. I guess I should go back and do that previous one by hand too, just in case anybody watching wants to do it by hand. So if you look on your chart, well, your tables, your formula sheet, normal distribution is right here. You convert it to a z-score, then you look it up on the chart. So I'll just do one of these using one of these by hand. I'll do B since it's slightly more complicated. So this is the same previous problem with the baby weights, but by hand. So this is the formula you use, x minus mu over sigma. But since we have to use the central limit theorem, we're going to divide that sigma by square root of n. So z equals x, 11, minus mu over 2.7 over square root of 64. So once we convert that to a z-score, we're just going to look that up on the chart. And I get negative 1.48. Look that up on the standard negative z-score chart right here. Standard normal distribution, negative 1.48, negative 1.48 is the second last column. And we get 0.0694. So P 0.0694. And if we notice, it's the same to 3 decimal places as if we did it with the calculator. You will get slightly different answers with the calculator and with the chart because the chart rounds to 4 decimal places for everything. Calculator doesn't round to the end. Technically, it's got about 52 decimal places. All right, now we're going to look at this one. And a sample of 26 hip surgeries of a certain type. The average surgery time, it's a sample, right? So X bar. And that's with a standard deviation of 22.6, so that's that sample standard deviation. And it says estimate the mean surgery time of all hip procedures with a 90% confidence. So that means alpha is 0.1. So right here, this tells us this is S, this is not a sigma. So that makes this a T problem. It's going to be a T interval. So here's the important information. TI users, you're pretty much done. Go to your stat, test, and number 8 is your T interval. Type the mess in and you're done.
Swallow, I know you told me yesterday, but what makes it a P? I mean, what makes it a T and what makes it a Z?
Right here. What letter is that?
Oh, okay, yeah. If it gives you the standard deviation versus the population standard deviation.
Correct. So
Okay,
that's
I remember now.
yeah, if that's a sample standard deviation S, then it's a T. If it's sigma, if it's your population standard deviation, that's when you got a Z going on. That works for your hypothesis test, your confidence intervals, anything you're dealing with mean. Uh, 120, so here's my interval. We're going to round these to the same decimal place as X bar. So 129.3 to 144.5. But wait, that's just this part, isn't it? So TI users, you're gonna have to do a little bit more work than just typing it in. If you take your upper bound and subtract your X bar from it though, don't round, 144.47 minus 136.9. Well, that right there gives you your error of 7.57. And you still have to look on the chart or use that inverse T program I told you to write to get the T critical value. It's a confidence interval. So that means we're always going to be dealing with a two-tail for confidence interval. So alpha is 0.1. We're going to look up the T critical value for alpha over 2, which would be 0.0. Well, if we look at it, our particular chart has area in one tail, area in two tails. So you'd look up 0.1 and 2 tails. But if your chart, if you're using a different chart, doesn't have this split up, the area in one tail would be half of that, 0.05. That tells us we're looking in this second to last column. N is 26. That means we're looking for 25 degrees of freedom. Right here, second to last column is 1.708. So that's 1.708. And that's the first step if you're doing it by hand or you don't have a TI. So once you get this, you can calculate your error with the error formula, which is also on your formula sheet. You look up top here, right here. Error is this. So that's how you do it. TI users, non-TI users, your first step is their last step. So you'd find the T critical value first. And then we plug it in. It is a two-tail, so just don't worry about the negatives going on until the end. We're going to add and subtract it to the mean anyway. Now, it tells us to round the error to 3 decimal places. On the TI, we only had 2 decimal places. So let's see what actually this pops out with. So it's 0.7570. Okay. So I guess we can shove a 0 on there if we really want to. Then if you remember your formula, we're going to subtract the error from the sample mean and add the error to the sample mean. That's our interval. So I'm going to store that to A, shift So A, clear that. 22.6 plus, well, actually, I'm doing the minus first. Minus A, might have a fraction type of 6. And that gives me, well, that's because I'm an idiot. I did this S instead of X bar. Yeah, I should pay better attention. My bad, 136.9. That's more like it. 129.3. We round to the same decimal places as X bar. And then I'm just going to go left, delete that minus and put plus, and I get 144.5. So the proper rounding rules for these guys are to go to the same decimal place as your sample mean, or one decimal place further than your data values. This one, I don't know about a rounding rule for probability though. So I guess we can write these in here. 1.708. 7.570. 129.3. 144.5. Yes, I should close out parentheses. And that's it. 3 points on the next one. You're increasing your confidence. That means you're making a wider window there. If you think about it, to be more sure, you have to include more numbers. So your interval will become bigger. And since we have a TI, we might as well just see what that would look like. Instead of 0.9, if we change that to 0.99, it's going to go from 124.6 to 149.3. Comparing that to what we had previously. Oops. You can see that this is a bigger range of numbers. The interval is wider. Let's see what number, we're on number 11. We might actually just finish today. And then we can use tomorrow for questions. In June 2009, who cares? Use this information to determine if a random sample of 7 gamers is selected, at least 5 of them have heard of the game. Hint, you can use the binomial table. Okay, well, if we look on our particular sheet, you guys don't have a binomial table. No binomial table here. What you do have, though, is a Casio, because I made sure you took one from school, which we'll need back, by the way, Monday. I think you're going to school. So that's what you're going to use. So I'm going to copy this down, write the pertinent information, see what we do. So it tells you right here it's binomial. So it's N, P, and X is what we're looking for. N, P, and X. N is 7 gamers, so 7. P is 20%. So that's 0.2. And we want at least 5. So translate that to a symbol. At least is greater than or equal to 5. All right. So now, if you do have a binomial table, you can easily just find what it is. If you're doing it by hand, we'd have to calculate the probability of X equals 5 plus X equals 6 plus X equals 7. And if you look at the binomial formula, I highly advise you know how to use a calculator for these. Where are we at? Sorry, never use it, so give me a second to find it. Oh, binomial probability. Yeah, here you go. You'd have to use this formula 3 times and add them together. Not what you want to do. So you'd have to plug in 5 for X in all these, get a number, plug in 6 for X in all these and get a number, plug in 7 in X for X in all these, get a number, and then add them together. Not going to do it. Your Casio and your TI can do it for you. You just have to remember how to translate these symbols. If you remember, a CDF is less than or equal to. So that's going to be N, P, and X, regular old CDF. It's binomial, which means the variables are discrete. You can't have pieces. So if you are strictly less than, you have to remove a whole number from X. So we're going to do X minus 1. So let's say we have less than 5 people. Well, how many would be the lowest number for less than 5 people? 4 people. Greater than or equal to, well, that's where you got to think. It's the complement of something. Greater than or equal to is the complement of less than. So it's 1 minus CDF, or use N, P, X minus 1. If it was strictly greater than, well, that's the complement of this one. So it'll be 1 minus CDF, NPX. And then if it's an equal to, that's a plain old PDF, point distribution function instead of cumulative distribution function. And then a not equal to would be 1 minus the PDF, NPX. So those are all the possibilities. I'm fine if you just go ahead and write it down instead of having to think about it on the test. So if we look at it, we have a greater than or equal to, we need to do this kind of thing right here. So I'm going to use a Casio first. I'll use the TI in a minute. So go to mode, distributions. And we need a binomial, not PDF, but CDF. You have to go down to the second set of distributions and do a number 1. Do we know the list of data? No, we don't. We got variables. What's X? Well, it's 5, but we have to take 1 away from that. So 5 minus 1 or 4. What's N? 7. What's P? 0.2. Oh, there we go. But that's also not done, is it? That's just this part here. So what we need to do is go to mode 1 and do 1 minus our answer. And it gives us this in scientific notation. That's a decimal followed by 2 zeros, 4, 6, 7, 2. So move this over 1, 2, 3 spots. We'll have 2 zeros here, 4, 6, 7, 2. So that'd be the probability. It says round 3 decimal places, so we'll do that in a minute. TI users, exact same thing. Second vars, that's where your distributions are. I'm gonna go up because I know it's kind of down there. It's a letter B if you want to do it that way. And I'm just gonna put random stuff so you can see. So if you do it, this is what's gonna pop up for you. It's always NPX for the TI. Casios are a different order, but it tells you what you're dealing with. So N, comma, P, comma, X. And we need to do 1 minus that. So I could actually have done that here. I could have started with a 1 minus and then done that. And there it is. Same thing. So 3 decimal places, that's 0.005. So if we look, we say it's greater than or equal to 5 is 0.005. And again, less than 5% we consider unusual, so yep, that's unusual. All right, second part's continuing. Calculate the mean and standard deviation. You have your formulas here. They're really nice, easy formulas for this one. Mean, mean and standard deviation. Mean is just n times p. So 25 times 0.2. Gives you 5. And that's standard deviation, so we need the square root of n times p times q. Remember, q is 1 minus p, so 0.8. And that's from this formula right here, n times p times q. Q is the complement of p. We get 2. That's all we needed there. And just second those. Okay. Sorry, my mom taking notes, make sure she's okay. Going on number 13 now. So this one gives us all the nice information we could ever want. And it asks if there's a correlation between altitude and outside air temperature. So notice that they don't give us the data, so we can't just type it in the calculator and push buttons. We have to type it in the formula. So we have to type the numbers in the calculator and push buttons. I believe that's chapter 11 for 10. Okay. Here's the correlation formula. Looks long and scary, but you're just typing numbers into the calculator. It's really not big a deal. Oh, the correlation coefficient for the bivariate data is that. We don't have to do any work, do we? Okay, why? I guess n is 6, so I guess we can use that. Look it on the chart. N is 6, so 0.811 or above is a correlation, 0.917 or above is a really strong correlation. It's 0.997, ignore the negative. So yeah, there is sufficient evidence to prove that there is a strong negative linear correlation. It's negative, so it's negative. We're always going to be dealing with linear, so nonlinear is not an option. If it's above this critical value for 0.01, you'd use a strong negative linear. If it's above this one, but not above this one, you'd use just a negative linear or positive linear. Positive. So that's a little different from what we've done. Are there any questions on that? Seems like no. So yeah, I was about to do all kind of work and they already did all the work for us. That's very nice of them. I don't know why they gave us this thing. Who cares? Oh, I guess because we're going to use it right here to get the regression equation. So I don't need this. That's correlation. We already know that. It gives it to us. I do, however, need to get B0 and B1. Again, button mashing. And I'll just do the work right here because I already have it there and the data is the same. Let's read the other question. Let's make sure these all match. Yes, they do. Okay. I'm going to calculate B1 and B0. I'm just going to type in the calculator. I'll do B1 in the Cas. I'll do U0 in the Casio because it's a little more. I'll do B1 in the TI. Just so you can see what it looks like. So TI users, let me make sure real quick. Yeah. Okay. So this is what it's going to look like for you. Always, always, always put your numerator and your denominator in parentheses. So I'm going to do this one, B1. N is 6 times sum of xy, negative 3016. Minus sum of x, 119, times sum of y, negative 7. So my whole numerator is in parentheses. Now I'm going to put my denominator in parentheses. 6 times 3139 minus 119 squared. Close that. So my denominator is also in parentheses. I hit enter and I get this number right here. Let's see, do we need to do any calculations with it? No, okay. So I'm not going to worry about saving it. It says rounding extra 3 decimal places. So that's negative 3.694. And that was B1, so that's our coefficient of x there. Negative 3.694. So pay attention to where the x is on here and where the x is on your formula. B1 is the coefficient of x. So whenever you find B1, that's the coefficient of x. Now for B0, I'm going to use a Casio because it's quicker. You've got sum of y, negative 7 times x squared is 3139 minus sum of x times sum of xy, negative 3016. Go down here, 6 times sum of x squared, 3139 minus 119 squared. And on that, you don't have to worry about parentheses, 72.102. Okay. And that's all you can do for that one. Two variables, blah, 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 predict the fuel consumption for a car traveling that much. So usually if we're going to do a prediction, we'd look at the correlation coefficient first and make sure it's actually correlated. If it's not correlated, we use y bar. Looks like for these, we're just going to have to assume they are correlated, which I mean, we know they are because of what I was talking about. We know that your speed and your fuel efficiency are directly related. Well, inversely, I guess. So we're just going to plug it in. So, oh, we got a question or something. I have to go. CSS. Yeah, I'm just gonna do the whole thing today because we're almost done, and that way I can have more time for you and Warren tomorrow, Go Bear. And we get 9.303. And that's what we're going to type in. Hopefully you've been practicing. All right, last two, they're hypothesis tests. A math teacher has developed a new program to help high school, blah, blah, blah. Sample student 25. Blah, blah, blah. First thing I'm looking for is a claim. You know what, I'm gonna copy this so I can highlight stuff. The first thing I want to find in here is what is my claim. Okay, at this significance level, does the program make the mean number of points of all students greater than 0? So that's my H1 is greater than 0. That makes my null less than or equal to 0 for my mean. So we're talking about mean is less than or equal to 0. Mean is greater than 0. And the claim is in the alternative. So they use HA instead of H1. Remember, I told you you could either use H1 or HA for the alternative. I like H1. So from here, we can say this is the right tail graph. And if, let's look some more. N is 25. They do that. The mean number of points improved was 2.5 with a standard deviation of 10 points. So it doesn't say population standard deviation. It's talking about this sample of students. So S is 10. That makes this a T. So now alpha being 0.05, we can calculate the test statistic right here. This is our claim, by the way. We put it on the Moodle document, but that's right there too. So my test statistic, T equals X bar minus the mean over S over square root of 25. Sorry. So 2.5 minus 0, 10 over square root of 25 gives us 1.25. And then they give you an option, p-value or critical region. So I guess I'll do both. P is I usually go with the critical region though. Oh, okay. Well, that's obviously not a p-value. Let's see if I put p-values as an option. No. So we have to use the critical regions, and we don't have to do any work because it's a right tail test. We know it's going to be positive, and those are our options there. So hey, that's work for us. So we don't even need to use a chart because it gives us the critical value there. Cool. If we did graph this, so this would be outside the critical region. So critical value is apparently 1.711. And we can go to the chart just to make sure. It's N is 25, so it's 24 degrees of freedom. It's 0.05 and one tail. That makes it this second last column here, 1.711. They didn't lie to us. You plot that terrible graph, who cares? Critical regions over here, test statistics right there. Yep, it's the test statistic is not in the rejection region, so we fail to reject the null. Better reject the null. Oh, hey, look, they're nice. We failed to reject the null. The claim was in the alternative, so there's not enough evidence to support the claim. There is not enough evidence to support the claim. So that's it for the hypothesis test on that one. I guess I'll do this one just from here. Differs from 30,000. So that's the claim. Differs from 30,000. So that's a not equal to. And of course, we're still talking about mean. If it's not equal to, it's equal to same number. The alternative, is there enough evidence to support the claim? Well, they say support, so it better be in the alternative. At alpha equals 0.01, the mean tuition fees for private institutions differs from 30,000. So not equals 30,000. The graph is two-tail. It's, let's see, a sample was that, assume the standard deviation for all. That's given us a Z. I can't just do that from the words. I'm guessing they want the critical. Oh, maybe they want the p-value. Maybe they'll let you choose. I don't know. We'll do it both ways. Z equals. I guess I actually need to write everything down now. So n is 39. We already have our hypotheses on the other one. So mu is 30,000. Let's write that. We'd usually have our hypotheses here, but they're over here for us. Sample was 30,500. Sigma, that's what's telling us the Z and not a T, is 4,500. So standard deviation for all private institutions. That's the population. It doesn't say about this sample of 39 colleges. Alpha is 0.01. And let's go with it. Z is same kind of formula as before, 30,000, that's X bar minus mu over sigma over square root of n. That's on your formula sheet. Right here. Well, right here. So plug that in and see what happens. And we get 0.6939. If I was a betting man, I'd say we're going to fail to reject the null. Oh yeah, definitely. Let's get the critical values and the p-value. Because I don't know, I guess we can do it either way. This one we didn't have a choice, we had to use the critical region. I guess because it was a t and the p-value is an interval usually instead of a value. Critical value, 0.01, but it's two-tail. Two-tail? Yeah, it's two-tail. So we have to take 0.01 and divide it by 2. 0.005. So that's what we're looking for. You could do an inverse norm and find out what it is, but I need the chart. 0.005. Where are you at? Where are you at? Oh, right here by this little asterisk. We use negative 2.575. Negative 2.575. So let's go ahead and fill some stuff in. The test statistic, 0.6939. They didn't want us anything about rounding, so I guess we're good. I like going 4 decimal places. That way, if I have, like I do here, 3 decimal places on my critical value, I can be sure that it's going to be covered. So I guess I could say critical value of, well, it's also going to be positive, right? It's a two-tail. Let's see if it lets me type it. 2.575, comma. Okay, we could do that. Or for the p-value, it's a two-tail, so use that little flow chart. Positive, so it's the right of the center. Find the area to the right of the test statistic and double it. So I'm going to look up 0.69 inside the chart here. 0.69, 0.69. The area to the left is 0.7549. That's positive, so that's to the right of the center. I need to 1 minus that. And then it's a two-tail, so I need to double that. And that would be my p-value. So I guess you could do either one. PI users, of course, you're done pretty much as soon as you write down everything. You go to your test, you have either a Z or a T. This one's a Z. Mu was 30,000. Sigma was 4,500. X bar was 30,500. N was 39. Two-tail, calculate it. Gives you your test statistic, gives you your p-value. So you'd be done. You'd use the, instead of the critical region, you'd type the p-value is 0.4878. We did it by hand, we got 0.4902. I'm sure they have a range of answers to accommodate that. They probably have 0.48 or 0.490 plus or minus 5 thousandths or something, who knows. But it's not gonna be wrong if you use a TI or if you use a chart. P is definitely greater than alpha, so we're going to fail to reject the null. It even tells you that right here, isn't that nice of them? P is greater than alpha, fail to reject the null. The claim was in the alternative, so there's not enough evidence to support the claim. We fail to reject the null, claim is in the alternative, not enough evidence to support the claim. That's what your final is going to look like, people. So, Joe Bear, do you have any questions?
Nope, I'm good.
All right.
Looks
Then,
easy. Are we gonna do our thing tomorrow for the other one?
yeah, at 1:15, I'm going to open up a Zoom for any questions if any of the stats kiddos have one. If they don't, we'll just jump right into the 170 thing.
Okay, good. I don't really I need help on a few things, not a lot of stuff, but I mean, I just need an overview of like all of it really. So
Yeah, we'll look at that one tomorrow.
All right.
Yeah, I'm not expecting it to be very long for stats tomorrow because look how many people show up.
Yeah, exactly. How many people are gonna fail, you think?
Well, technically, there's 2 students that can't pass right now, but if they do really, 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 really well on the final, I'll nudge them up a little bit.
Yeah. Well, that's good. So
Yeah.
how much do I need to get for an A?